This is S4 National 5 homework due Friday the 3rd of June. Starting with the non-calculator side, question 1, we've got an inequality and an equation. We solve them in the same way, using the same method, trying to balance both sides. So your first step is to try and get rid of this 2, because we want to get rid of any fractions. So to do that, we're going to multiply everything by 2. So if we were to multiply that by 2, the 2's would cancel. So we end up with 3 times 4 minus 2x is more than or equal to 24. Your next step is multiply out the brackets and then get your x on one side, your numbers on the other, and balance the equation until you have a value for x. Part B is done very similarly, the only difference is we have an equal sign. Question 2, there are a couple of different methods you can use for this. I tend to start by making them top-heavy fractions. So 4 times 3 is 12, add 3 is 15, so 15 over 4, plus 6 times 2 is 12, 12 add 5 is 17 over 6. Your next step is then to make the denominators the same, and then it's a simple addition. For question 3, you need your laws of indices. So if we have a to the power of n to all of that to the power of m, we get a to the power of n times m, so we have to multiply the two indices. If we are dividing, so if we have a to the n divided by a to the m, then we subtract the powers. So you're going to have to use two laws there. Be careful with your negative numbers, it is to the power of negative 2 on the bottom. So remember what happens when you subtract negative numbers. Question 4 asks you to find the gradient and the y-intercept for this equation. Your first step is to rearrange it into the form y equals mx plus c. So you want to bring minus 4x plus 1, you want to bring it to the other side. Remember, your gradient is m and your y-intercept is c. So that would, your coordinates would be 0, c for the y-intercept. Okay, another factorising question similar to last week. Again, it's up to you what method you use. I'm going to multiply 2 by 12 to get 24 and list my factors. Now remember, I want two factors that when added together give me minus 11. Now, in order to get a negative number, but when multiplied together to get a positive number, they both need to be negative. So think of your factors, negative 4, negative 6. Okay, negative 4, negative 6, that gives me negative 11, so I'm going to stick with that. Next step is to rewrite the initial equation, but instead of minus 11x, I'm going to use minus 4x minus 6x plus 12. Okay, once you've done that, treat both parts, the two parts separately, find a common factor in each, and continue until you've got your two brackets. Question 6 is multiplying out the brackets, so just make sure you multiply everything in the first set of brackets by everything in the second set. Once you've done that, make sure you collect like terms and simplify. Question 7 is simultaneous equation. We are told that we need the total cost for an adult ticket and a child ticket. So we're already told in the question that adult is A and child is C. So you want to set up two equations using A and C. Once you have your two equations, go on to solve them simultaneously. So either your A or your C has to have the same coefficient in both equations by multiplying them, and then you can take them away from each other in order to solve. Once you have a value for one of them, substitute that value into one of the equations. Moving on to the calculator side, question 8. There's a few steps to this using the volume of a cone, 1/3 pi r squared h. You firstly want to work out the volume of the larger cone, imagining that there's not a bit missing on the top, and then the smaller cone on top, and take them away from each other. Question 9 is a depreciation question. The fact that it says depreciate means we want to do 100 take away 5 because it's 5% less each year. So that gives us 95. Your next step is to put that to the power of however many years we're trying to work out the value for. So it's depreciated over a period of 3 years, so n needs to equal 3, and then you multiply it by however much it was initially. So when it was valued to 3 years ago, multiplied by 95 to the power of n to find out what it's worth today. Remember, answer to the nearest pound. So it specifically has to be to the nearest pound, and also make sure your units are correct.